Hello, good morning students. On behalf of this Vidya I am welcoming you on this online studies in Standard 9 Science. Today we are going to start our next topic in the chapter number 10, Gravitation. But before we going to start the next topic in the Gravitation chapter, let us take a brief preview on what we have studied so far in this chapter. So first we have learned about the concept regarding the gravity or the gravitation force. The first thing that we have understand regarding the gravitation is what? That basically whenever two objects come in the contact with each other, they both experiencing some kind of force between them. I'm sorry. And that some kind of force is basically known as a gravitation force. The gravitation force is not only applicable to the objects, but it is applicable to the any two things or any two objects. For example, we can consider our sun and our earth will be rotating around its orbit around the sun in its orbit because of the gravitation force. The moon is also revolving around us due to the gravitation force. So likewise that whenever two objects come in the contact with each other, or if they will not come in the contact with each other, they both will come in nearby each other, they will experience some kind of force between them. It is considered to be a gravitation force that we have already studied. After that we have seen the basic summary that we are going to see in this chapter. Now we have seen that what is the importance of the gravitation force. So we have seen the ideas regarding that because of the gravitation force, the atmosphere is also surrounded by us. Otherwise, atmosphere can also not stay over the layer of the earth. It is also thrown away in the space. But due to the gravitational force, the atmosphere is can be stayed here. Also, we have seen that we can walk on the surface of the earth. Whenever we are riding a vehicle, it is because of the gravitation force. Okay, so that are the basic concepts that we have seen so far in these chapters. Now in this lecture we are going to study about the universal law of gravitation, in which we are going to see about the basic idea that has been given by the Newton, that on the which facts or on a which quantities the gravitation is dependent upon. The first thing that we are going to discuss about this gravitation force is on the which factor it is dependent upon, on the which quantities it is dependent upon. Because so far we have seen that the gravitation force is experienced whenever two objects come nearby each other. Then and then only a gravitation force can be experienced. But the characteristics for what they are applicable, the basic things, the basic factors that they are dependent upon, the gravitation force is dependent upon, that we are going to study in this lecture. But going on to that, we are also going to see some of the facts regarding the gravitational force, that why it is so much interesting topic. Okay, we are going to see also that, and after in the last session of this lecture we are going to see about the SI unit of gravitation force, that how it came, and I have already given you the idea regarding the SI units, that it is a standard international unit. So in the all physical quantities, whatever we are studying in the physics, it has been discovered and it can be identified by its SI unit. So for that we are going to learn about this universal law of gravitation, and afterwards we are going to derive the equation regarding the gravitation constant, and then we are going to derive the SI unit for this gravitation constant. Okay, so from that we can identify this gravity. Okay, so let us start our today's lecture. Okay, the first thing that we are going to start is the facts regarding the gravitation. These are all the studies that we have already finished in the previous lecture, so I am not going to waste any time in this. So a few facts about the lunar tides optional reading. See, this is the optional reading because it's a facts regarding the gravitational force. So first point, the gravitational force of the moon is 110 millionth that of the earth. But when you combine other forces such as the earth's centrifugal force created by its spin, you get tides. So the tides that we are experiencing, it is because of the moon's and our centrifugation force between them, and that is why we are experiencing a low tides and high tides in our sea waves. Okay, the sun's gravitational force on the earth is only 46% that of the moon, making the moon the single most important factor for the creation of tides. See, that is the important point. The sun's gravitational force on the earth is only 46% that of the moon. Whatever the force we are experiencing from the sun, basically from that portion, from that force, the moon is only experiencing a 46% of that. Okay, whatever, if we are experiencing 100% of force of the gravitation from the suns, then moon is considered to be a 46% of our gravitation force. Okay, if we are experiencing a much more higher force, it will experience a much more higher force. If we are experiencing a much less force, then it is also experiencing a less force in regarding of the 46%. So it is making a single most important creation for the tides, because we have no such a artificial satellite or natural satellite surrounded by us. So that's why it is a only factor. It is only one natural satellite that we have, and that is only responsible for the centrifugation force between us and it, and then it is produced tides. Okay. The sun's gravity also produces tides, but since the forces are smaller as compared to moon, the effects are greatly decreased. The sun's gravity also produces tides, but the forces are smaller, so the effect of these tides is also less regarding in comparison to the moon. Because moon is so much near, and that's why we are experiencing tides, low tides and high tides because of it. Also, some amount of low tides and high tides is dependent on the suns also, but we are experiencing a less gravitational force between sun and us, so that's why we can say that it will not impact much more, okay, rather than it is impacted on us. Okay. Tides are not caused by direct pull of the moon's gravity. The moon is pulling upward on the water while the earth is pulling downward. Slight advantage to the moon, and thus we have tides. So these are the basic facts regarding the tides, that whatever we are studying here. Okay, tides are not caused by the direct pull of the moon's gravity, but moon is pulling upward on the water while the earth is pulling downward. Okay, so the moon is experiencing a gravitation force, and it is making an effort to make a water level rise. Okay, it is making an water to go over there, but we are making an effort. Or whatever the force has us have that experience that given us the water level rising from beneath our surface layer. Okay, so it making an effort to pulling towards it. Okay, while we are making an effort to stay here. Okay, that's why we are experiencing this low tide and high tides. Okay, whenever the moon, earth and sun are aligned, the gravitational pull of the sun adds to that of the moon, causing maximum tides. Okay, so whenever these three forces aligned with each other, it will make a causing of the maximum tides, and that will be maximum. If maximum tides will be happen, it will be considered as a tsunami. Okay. Spring tides happen when the sun and moon are on the same side of the earth or when the sun and moon are on the opposite side of the earth. Okay, that's the basic idea. But the important topic is for today's lecture is here now. Whatever we have seen so far is a basic facts regarding the gravitational force, also regarding the tides. Okay, but today's important lecture is this: Newton's universal law of gravitation. Already we have seen such an idea regarding that whenever two objects come nearby each other, whatever the force they are experiencing, it is called the force of attraction, or it is also called the gravitation force. Okay, whenever two objects. Okay, so now in this law we are going to see about that on what factor this gravitational force is dependent upon. Okay, on what factor it is basically dependent upon. So first point that is given in this idea, in this law, sorry. So this is the law. You will have to memorize that. Okay, because we cannot change the statement in the laws. Okay, already I have told you in the classroom that we cannot change the statement of the laws. Okay, all the definitions for the physics. Okay, so we'll have to remember that. But we are going to understand that what they are going to talking about in this law. Okay, so we are going to see that. Okay, the first point is that everybody, we will change the color. Okay, orange color maybe. Everybody in the universe attracts every other body with the force which is, okay, so it is the point that you already understand. Okay, but the point that you are going to understand is a force which is directly proportional to the product of their masses. Now what they are going to say that whenever two objects, here is the example, but I am also giving an example. Whenever two objects, suppose this is the object A, okay, and this is object B. So in this universe, whatever the objects or whatever the bodies have their own mass. Okay, so regarding that, if they have own mass, suppose the object A has a m1 mass, object B has a m2 mass, then the force is directly means what? It is directly dependent on, means whenever you are changing the mass, it will automatically changes the force. Okay, whenever you are changing the mass, it will automatically changes the force. Okay, so that is, it is it is called the directly. Okay, means whatever a minor change can be occurred. If you increase the mass, it will increase the force. If you decrease the mass, it will decrease the force. That is a directly dependent on both the factors. So mass is directly proportional to the product. Product means a multiplication. Okay, product means a multiplication. Now the things you are going to understand is the proportional. So proportional can be determined by this letter called this. Okay. Second. Otherwise you will think that the m1 is proportional to m2. That's why I have erased that. Okay. So that is the sign for the proportional. Okay. Now that's the signature we are going to use to identification for the proportional. Okay, whenever we are using, it means that whatever the things that we have written on the left hand side and right hand side is both dependent on each other. Things like this is directly proportional. Other thing that came to study this law is the inversely proportional. Means what is the inversely proportional? if we are increasing other quantity on the right side, then the automatically left hand side is going to be decreased. Okay, if we are going to decrease the left hand side quantities, it will increase the right hand side quantity. If we increase the left hand side quantity, it will automatically decrease the right hand side quantity. So like that, we are going to study about the proportional and inversely proportional, both the thing in this law. So first point is which is directly proportional to the product of their masses, means their masses means this both M1 and M2's product is directly proportional to the force. Okay, whatever the force that we are experiencing, it is the multiplication of these two. Okay, then is, here is the another point, and it is inversely proportional. Now how can we determine the inversely proportional? So if we write 1 upon whatever the thing, then it can be considered as an inversely proportional to the square of the distance between them. Now these are the two factors. I will explain you. I have to take one blank slide. Next we will explain you there. Okay, here it is a blank slide. Now let us discuss the things that we are going to study in this law. Is the force is basically dependent on two things. Okay, the first thing is the mass, and second is distance. Okay, also we have seen this is the sign that we are using to proportional. This is the sign that we are using for the proportional. Okay, it is a distance. Okay, I think it is look like distance. So this is the distance and mass, the both quantity that is affect the force that the two objects is experiencing. Now these two objects are shown here. A object and this is B object. Now they both are experiencing some kind of force between them. Okay. Object A has a mass m1. Object B has a mass m2. And the distance between them is supposed to be a d. Okay, means the object A and object B are from each other from the distance of a d. Okay, they are away at a distance of d. I hope you all are understanding this. This is a mass and this is the distance. Wait a second. Sorry for the technical error, but I don't know what is going. What is happened here. So I have written another time these all the things, okay, because it gets erased. Okay, so sorry for the technical error. But as we are experiencing that, as we are discussing that, that the two objects are experiencing some kind of force between them. The object A has a mass m1, object B has a mass m2. They both are away from at the distance d. Okay, the first thing that we have discussed in the universal law of gravitation is that the gravitation force is dependent on mass of that product. Means what is the object, what are the object's mass? So here is the m1 and here is the m2. So it is basically dependent on what we are going to use the sign. We are using the sign of proportional. Onto that, what we are discussing, the mass of their products. Of their means object A and object B's product, or sorry, object A and object B's mass of mass product. So m1, okay. m1 multiplied by m2, because the mass is different for object A and object B. That's why I have written m1 and m2. Otherwise, if the object A and object B has the same mass, then I can write m into m. It will give us the m square idea. Okay, if the object A and object B both have the same mass, then it will be considered as a m square. Okay, but they both have not the same mass. Okay, like we can understand that it has a 15 kilogram of mass and it has a 20 kilogram of mass. Then what we are going to do? 15 multiplied by 20. Okay, so this is the basic idea that what we are going to do, m1 multiplied by m2. Now other thing that is given by the law, that f is inversely. Now how can we write the inversely? Already we have discussed, we have to write 1 upon whatever the quantity. Okay, that is given us the idea regarding the inversely proportional. Now the inversely proportional based on the distance square. Means whenever we are increasing the distance, you automatically know that whenever we are experiencing, if these are the two objects, okay, then these two objects goes away from each other, what they will experience, they will automatically experience a less force between them. Okay, whenever they come in the contact with each other, they will experience a much more force between them. So likewise, that the distance is always inversely proportional to the square of the force. Okay, it means 1 upon d square. Okay, means on the basis of the distance square, the force is experiencing a inversely proportional fundamentals. Okay. Now these both the things you can understand. Now I will merge this both thing into one. Okay, I will merge this. So force proportional to m1 into m2. Now into means a multiplication, okay, upon d square. This gives us the basic idea of the universal law of gravitation. Okay, that the universal law of gravitation. Okay, we will go to the first page that we are already discussing, that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, now here is the example that we have already discussed. See, this is the object A, object B, this has a mass m1, this has a mass m2. They have given us the distance between them by giving an alphabet R. We have taken the alphabet D. Whatever the alphabet you want to take, you can take it, but D and R are the basic idea to identification of the distance. So that's why we are using the D and they are using R. So not at all a problem. Okay. Let two bodies A and B, masses m1 and m2, placed at a distance R from each other, then the force attracts directly proportional to product of their masses, means F proportional to m1 multiplied by m2. And second thing, the force attraction inversely proportional to the square of the distance between them, F proportional to 1 by r square. We have taken a 1 by d square. Then here comes F proportional to m1 multiplied by m2 upon r square. Okay. Now what is the other thing that we are discussing is what happens if we remove this proportional sign with the is equal to. Okay, because in the mathematics we have seen the is equal to sign. We are not using the proportional signs. Okay, because it is continuously changing onwards. That's why. So whenever you are using an is equal to sign instead of the proportional, then you need to put some kind of constant in the equation. Whatever the equation you have derived already, you will have to put some kind of constant for the removal of the proportional. Now constant means A to Z, whatever the alphabet. Okay, whatever the constant you want to use, you can use it. But in this chapter we are studying regarding the gravitation. That's why we are using the constant G. Now what we are going to do? Okay, I will take another color. That will be pink one is better, I think. So if we remove F is equal to, now we are removing this sign with the is equal to. Okay, is equal to is equal to sign, then we need to add some kind of constant because we have already discussed. Okay, so constant we are adding is G into m1 into m2 upon d square. Now this G is known as a universal gravitational constant. I hope you all are understanding this topic, that force is now can be considered on the basis of these three things: gravitational constant, mass and distance. Now I am going to erase that. Okay, I will not erase it, but I will add some new slides so for the basic idea of yours. Okay, that is not working. Wait a second. Okay, now here it is. Okay, but we'll have to erase that because I have written in this board, so sorry for that, but we'll need to erase that. Okay, now I am going to write that force is dependent on, so basically force is dependent on mass 1 multiplied by mass 2 upon d square. Then what we have done? We have removed with G m1 multiplied by m2 upon d square. Now what we are going to do? We are going to do a G is here. Now G is here. Now what we have earlier seen in the mathematics rule, that whatever the things is in a denominator, if it comes over here, it will come in the multiplication, that f multiplied by d square upon these are the things in the numerator. If it will come on this side, it will become in the denominator m1 multiplied by m2. Okay, so this is the basic idea for the gravitational constant, that what is the value of gravitational constant. It can be measured by this thing. Okay, this is a very easy, if you just remember the law regarding the universal law of gravitation. Once you will learn that, you will understand the fully concept regarding this. Okay, if you don't understand this concept, please revise this lecture. Okay, now we are going to make the SI unit. Now SI unit means what? Whatever the unit so far we have seen in this physics chapter, the first thing, gravitation units is the force. So what is the unit for the force? The force unit is Newton. Now D means distance. Distance unit is, already you have known that, meter. And then mass unit is kilogram. Okay, you already know that. Now we are going to put this all the things. So what is the unit for the force? It is Newton, newtons, and okay, I will write that. Newton into distance square means one distance as a meter unit. So if a distance square gives us a meter square unit, so meter square upon a mass means a mass 1 has a unit kilogram, mass 2 has a unit kilogram, then kilogram into kilogram, it gives us the idea of kilogram square. This is the unit for the gravity. G is dependent on Newton meter square upon kilogram square. This is the SI unit for the gravitational constant of universal gravitational constant. Okay. See, so that's it for today. It is an important topic regarding the gravitational constant. In today's homework, we'll have to write this. Okay, I'm writing the homework here. Right. Right. And derive universal law of constant with its SI unit. Three times. Why I have given you this 3 times? Because it is very important. Okay, first, once you understand this topic, you will understand the whole topics in this chapter. Okay, so that's it for today. Thank you very much for this lecture. If you had any kind of doubt, you can ask me on the comment section. You can ask me personally on WhatsApp, or you can ask me by personally contact me. Okay, till then, stay safe, stay home. Please wear a mask. Please sanitize your hand. Okay, we are on the peak of this Omicron virus, so that's why you'll have to stay at home. Don't go outside. Okay, don't play around outside. Okay, please stay safe, stay at home. Okay, we'll meet in the next online lecture, and we are hoping that you are all experiencing and you are all enjoying this online studies. Okay, we'll meet in the next lecture. Till then, bye bye everyone, and take care of yourself.